Hi and welcome to the third video in this series of creating an animated spring assembly using a bolt, a spring and a square washer. In the previous videos we looked at creating the LCS systems of the spring, bolt and square washer and introducing assembler to you if you're new in that subject area. In this video we're looking at completing the assembly. So we've already assembled the square washer and the spring. We're now looking to complete this assembly with a bolt and start adding the animation. And we're going to be using a variable for that. And there's going to be a few warnings around that area, but we'll get into that shortly. If you like this video, please hit a like and also subscribe to the channel. I also have a Ko-Fi site where you can actually donate to my contributions to the community, and that's at ko-fi.com/MANG0. So there's a little warning here in that we can get into something called a DAG error. And this is easily resolved if you know how. So the reason why we're using a variable is just to allow for this to work. We'll be using Python later to control our animation. This is just to test our assembly. The way we hook up the variable to our spring, we need to come into our spring model. Now you won't, if this is the first time you'll be using assembler for, you won't know what on earth I'm talking about. You won't know what's on screen. But this is the thing that I just need to pay attention of, because you can, if you go away to lunch and come back and your model doesn't load, then this could be the issue. Because we're using a variable, I'm going to be using the helix of our spring. Remember we added the helix in and added the adaptive pipe, and I'm going to be changing the height of this helix. And the way I change the height of the helix is attach it to a variable that's in the spring assembly. When we import items into an assembly, they are actually externally referenced. Of, say, if I increase this pitch or assign it to the variable in the assembly, then that change will take effect in the external file. And the minute you save this assembly, it will ask you if you want to save the external file. If you do save the external file and the spring is saved, then this is going to cause you a bit of a problem if you try to reload it. It's easily resolved, but this will actually disappear when we start creating our animation for real, when we start using a macro. And I'm going to demonstrate that problem. So I've added this variable in here. If we look at a spring, you can see the variable has come across. Let me just remove this variable. So I'm just going to take a copy of this and just clear it out there. And what happens in our spring? The same thing happens. So we've got external reference to our spring there. If I come into the spring assembly, go down to the spring that's been reported in, we will go through that shortly, and change this height to be that variable. That's pulled, you can see it's got 40 millimeters there, it's pulled it in from the variable. That's sitting in our assembly. So variables, spring height 40 millimeters. Change this. Spring and bolt changes, spring height changes, etc. Now if I save this, you can see what's come down here. It's got the graph. Must be a DAG. It's called an error there, but it's just really for our animation, to get our animation right. So I'm going to go something like 40 to 80 in there. Steps 4 and run this. It's just to get this right. So if so you can see the spring has actually increased in size as well, and Saving that, we get the DAG error, same here. Then if I close this, I get save all and reopen Freecad, reopen my assembly, you can see what's happened. We've got a problem. Our assembly doesn't have any parts in. I know they're referenced over here, but look at what's happened. It's gone very strange. Everything's gone to a link rather than a part, and we have issues. So the easiest way to resolve this is just go back to the helix, which is here, and remove that variable from there. But you can see it's not there because it's not actually connected to that external file at this point. That's broken. So if we go to the spring, come down to the helix, you can see it's not there as well. So what we've got to do is actually load that file. So let's close that file, close all, close without saving, and now we just want to open the spring itself. So we've opened the spring, and if we look down, you see the spring assembly is sitting there. We'll open that up and you can see variables are sitting there. So we've got this kind of link back here. It even says the file name where it's linked to. So jump into the helix. Let's go into here, delete or clear. That's cleared out now. Save that. Close all, reopen our spring, and now that's gone. So you can see that's gone now. There's no spring assembly associated with it. Go to the helix, that's all good. And if we go into our spring assembly, you can see the helix has been selected in there, but I don't trust that, so I'm going to select the helix in this here, and everything has loaded. So before there was nothing in here, everything has loaded, so we're all good there. And what we need is a piece of code to actually control that external geometry or that external file, and we'll get to that as we're going through this tutorial. Now our spring is connected to our washer, we're going to set up the variables and the functions that we need to actually control this washer. Now there's no programming involved, these are just basic and simple equations or functions that we place into our function field. So to do this, I'm going to first come over to the variables. So in model we got this variables that is grayed out. At the moment there is no local variables in here. So to add a variable, we can click on the variables here, drop it down and add variable, or we can come up to assembly and add variable here. Now this is going to be controlling the height of this spring. So I'm going to call it spring height. And we're going to set the value, so the initial value of the spring. Now I'm going to set the initial value to what it is at the moment, which is 40. And that's the spring at rest. So that's what our spring height will be if there was no load placed on it. I'm going to OK that, and you can see the spring height is placed over here. And we can change this if we so desire, but it's not connected to anything, so it won't change. Now we're going to connect that up to our spring. So I'm going to come down into my model. So if we go into our spring part, which is here, open that up, and we can scroll down to our helix. And we're looking at the height. We need to change the height, and then we've got to put a small equation in for the pitch. So at the moment we're looking at 40 divided by 4 equals 10. So this is our pitch. So let's place our equation in here. And I'm going to type in height, which is the current height of our object. And make sure we spell it correctly with the correct case as well. So height, so you can see the result is 40, which is this one, and then divide that by 4, that's 10. So that will keep the pitch in union with the height. Depending on how many turns you want in here, then this pitch will differ. So now we come down to the height. You can see the equation sitting there, and click on the little icon, that function icon at the end. Now we need to pull in the variable from here. Now normally you would type in variables, but as you can see it's not there. So we need to reference outside. So we need to go to the top level. So using the chevron or the triangle bracket, put 2 of those in there, and you can see we've got a number of things in there. Now we want spring assembly. So if you use the arrow keys, go down to the spring assembly, and it'll place spring assembly followed by a hash. Now if you type in capital V, you can get to your variables, and then it'll put a dot there, and then spring height, that's 40, and then OK that. So now we have the equation for the height and the equation for the pitch, and the height is controlled now by the variable. So if we go back up to the variables, and if we change this variable to something like 84, click off, then that will change. Go back to the helix, come back down to the pitch and the height, and you can see those are changed there. Same changes to the variable now. So go down to 40, hit enter, we'll change this pitch and height. So this is a great way of externally referencing the model and then using these variables within. So now this moves up and down, and we can check that. I'm just going to hit Control S to save that off with our animate assembly, or assembly and animate assembly. Now be careful with this, don't press run because there's a lot of bugs around this. If I hit press run now, this will go into basically an infinite loop, and it will freeze up Freecad, and you'll have to control delete it or force quit. So make sure that your range begins at 0. Don't make this minus 40 either, and this one's 0 because that won't work either. So range, I'm gonna go from 40 to 80. And I'm going to do it in steps of 3, so it will go 3, 6, 9, etc. all the way up to the top range of 80. Let's push this aside, hit run, and before I hit run I'm going to put a pendulum on there as well, so it will pendulum back and forth, and run that, and you can see our spring is now moving up, and then once it gets to the top it will move back. So we started animating our spring now. So now we want to get the bolt in. So let's stop that. Close that down. And we'll just save that for now. And we'll move on to getting this bolt. So now we're going to attach the bolt to our assembly. Now if we look at this part, we've got this washer and spring. So I want to attach the bolt to this. Now there's 2 ways of doing this. We're going to look at both, and the first one we're going to be looking at is adding a coordinate system to this spring. So I'm going to jump over to our spring, and we're going to add a coordinate system to this. Now we have to be careful, because if we think about it, we've got an adaptive pipe here which changes. So we need to place it on something that we can actually connect the coordinate system to. Now if I select the adaptive pipe, so I'll select this face, you notice the coordinate system is grayed out. And you can see it's grayed out here as well. But you can see this little point in here, just there. That's the actual helix. So if I hide that adaptive pipe, and what I want to do is add it to the vertex on that helix. So we're going to place a coordinate system on this point. So we'll go up to our spring part, add a new coordinate system, and we're going to call this LCS bolt. Hit OK. Now let's get to that vertex on that helix there. So scroll in, we can see that vertex there, helix vertex 5, and we're going to place it on translate origin. So that's sitting there. It's best to see, if you have problems with these, just click the different ones and see which ones come up. So you've got an error there, and translate origin will do for that one. That's okay, so okay that. So that's sitting there. And I'm going to jump over to the bolt now. And we can see we've already added that there, which is going to be attached to the spring. So I can come in here and rename that if I so desire. If it's not attached correctly, look at the map mode and click on the map mode. There's 3 icons there, and we can change the placement of where that's going to sit. But I'm quite happy with where that is. I can cancel out that. And I'm going to right click and rename that LCS and change that to spring. Jump back to the assembly now, and we can see, because we've hidden the adaptive pipe, we've just got this spring in there, the actual helix, which is fine. It's actually quite good because we can see what we're doing. Now let's import that item, so we need to click on the model, import the bolt by clicking on the insert a part, click on bolt, insert, and the bolt's been placed in, but we need to connect it to the spring. Click on the LCS on the spring and the LCS on the bolt, and that's connected those two together. Now let's put it into the center there, which is not really where we wanted to go. We could change the LCS on the bolt so we translate it over here, but we can do that from here anyway. So let's have a look at what we got. So it looks like it's along the red, and the red is our X. So we go to our X and change that so it comes into right position there. So look at it from the top. It looks about right. We can do some finer adjustments later. And just scroll to the top and hit OK. So let's run that animation now. I'm not going to turn on the adaptive pipe yet. Making sure we set the range, because remember this will change, and it will always, the range begin will always become the range end, and it will cause you an issue. Let's run that and see what we get. So we can see that is working. Let's put our bolt up and down through that center hole there. Let's stop that, close it down, and switch the adaptive pipe on. Now we can do that by going back to our spring and just enable the adaptive pipe, and that will appear on there, or we could do it via the model down the bottom. But it's well worth doing it from the actual original model in case you hit some issues. Let's run that animation now. Remember, making sure starts and ends are different, and we'll run that and just move this out of the way. So we can see a nice movement of our bolt going up and down through our square washer. And working absolutely fine. Now I'll show you this of how to do the same movement but using a sketch. So we'll be attaching the bolt to the sketch and have that attached to the variable, which also moves up and down. You may want that in instances where you want to do something quite unique with the springs, something more complex, but this will get you through for the majority of applications, but I'll just give you that one just to show you. So for this one we're going to actually use a master sketch, and to do that we are using the assembly itself, or we could use a part. It doesn't matter, we can create the skeleton in a separate part, but this is a very simple master sketch slash skeleton that we're going to create. And I'm going to go into the parts, and I'm going to create a new sketch in here, and I'm just going to call this master sketch. Hit OK, and I'm just going to hit OK for that one for the time being. Now our master sketch has been added to the parts, so our master sketch is here. Let's double click on it. You can see that it's placed it on the top there, which is fine, and this is the reason why I prefer to model outside in a separate file and import the parts, because you'll end up placing the part into your assembly, so you get duplicate parts, which can be quite confusing. So I'm going to just hide the model for the time being, and I'm going to create a simple line and attach that. I've got the auto constraints on at the moment, so I've got to task, the auto constraints are on, and that I'm going to attach it to the center point and just come out, and I can also attach it to there as well. So that's our line. I'm going to put a length on that, like so, and I'm going to use the function on the end. Now let's hopefully we can get to the variables. So typed in V, we've got our variables, and I'm looking for spring height in there, and hit OK. And also OK that. So at the moment we've got 80mm spring height, and we're going to attach a coordinate system to the vertex there. It's not advisable to actually attach it to the line, because when this shrinks down we can get some obscure effects because our line is too short for our attachment. So it's better to use the vertex at the end here. So let's close that. That's our master sketch in there, and sitting there I'm going to create a part in here like so, and I call this master sketch part, and I'm going to place that in here as well. And what I'm going to do is just double check that that still got the variable attached. So we've got variable spring height there, so that's good. Cancel out that and close that. So we've got LCS system there, that's been added automatically, but it's not actually attached to anything. So I'm going to attach this LCS by clicking on the map mode, and I'm going to attach it to this vertex. Now it's essential to get the correct vertex, and I'm not sure which one's which, so I'm going to just OK that for a second and jump back in the master sketch, and I want to attach it to this vertex because obviously this is going to be moving up and down and this is going to be stationary. So I'm going to use a little circle, click on that vertex in there and just create a circle. So I've attached that to that vertex, and I'm going to just click on that circle and just add a diameter to that, so 5, so we know which one we need to connect that to. So let's see if we've got the right one. Let's close that. Lucky enough, we've got the right one. So that's sitting there. So when we run this animation, remembering that we need to change beginning range, it needs to be smaller than the end range, and run that, we see that nothing's happening at the moment. Let's stop it and just place that somewhere. And it's probably because we have got the master sketch not in our model. So let's edit. We can see the refresh is available. Hit refresh, and that has moved. So we know that is moving. And we can check that by coming down to the variables. Change the spring height to 40. Clicking off, and that has moved. So we know that's working. It's just not updating, but that will be updated once we get it into our model. So we've got the LCS sitting in there. We can rename that if we want, but that's going to be attached to the top of the bolt. So let's rename this LCS to LCS_bolt. Now we've renamed that. Let's bring our master sketch into our model. So let's enable the model. So now we've created our master sketch. What I'm going to do is remove the parts and rebuild this scene, so you can see how the master sketch comes into effect. So we're going to come into our model and we're going to start removing the bolt, the spring, and I'm going to leave the square washer in there, which has been attached to assembly, which is fine. What I need to do is first attach this skeleton to the washer. Now we've already created the top of this, which will move back and forth. So this LCS system will move back and forth, so we need to attach the bottom of this skeleton in the middle of this square washer. So you can see how confusing already, because it looks like our skeleton is already in there. And if we've done this in an external part, then we'll be able to not see this part sitting here because it won't be in here. It will actually be in the model when we imported it. But it's fine. So we've got our square washer in here, and I want to connect this to the center. Now we've only got one LCS on here, so we need another. So I'm going to hide the model and add another LCS to this vertex there. So we go up to our master sketch, come in here, add an LCS, and I'm going to call this one square washer. And we're going to select where it's going to attach to. At the moment it's placed it in there, but it's not attached to anything. I'm going to go for that vertex there. And we can select where we want to place, and so I'm going to go click on this one here. And we can see that's positioned nicely. So that's okay that. So we've got two attachment points now, and I can jump into my model, and you'll see where this gets a bit confusing now of having a model and the part actually built inside this part directory. I'm going to import the master sketch, insert that, and I'm going to insert it to the square washer. And I want the LCS from the square washer to LCS1 there, looks like we've got two. We've only got one. And I want to rotate that along the, I believe, not sure what axis that is. I believe it's the x-axis. No, it's not. Let's try the y-axis. There we go. It's the y-axis. And okay that. And you can see it looks like we've got two parts there, but if I come up to this mask sketch and hide it, it's now hidden. And that's the problem when you have mask sketches and parts in the parts directory and built within the same assembly file. That can be complicated. External files are so much easier to use. Just going to save that and save all the external files. Now we've got that, I'm just going to fit the section to our view, and I'm going to progress with adding the bolt. Now the bolt's going to attach up here. So back to models, insert a part, come to the bolt, insert. We're going to use the LCS1 spring on the bolt. We're going to attach it to, this time, the master sketch, and LCS on the bolt. Now I need to rotate that 90 degrees. There we go. So that's going through the center there. So okay that. So when we run the animation, that will move up and down, and then we just got to add our spring. Start the animation, and remembering that our variable is also controlling our spring, so it's just a case of actually fitting the spring in here. So let's get the spring in. So click on the model, import, and spring, insert. And that's almost there already, so we want to connect the spring. Now I'm going to use the washer, and I'm going to select the washer from here, connect it to the spring, and that's obviously a bit out at the moment, so we need to rotate that along the axis. Is that's the green one. You can see the green one in there, goes up. So if we zoom out, you can see those axes growing, so you can actually see what they are. So that's green, so we need to rotate around that. So green is Y, rotate around the Y axis and place that in there, and that should be it. So okay that, those are all in. Let's run the animation, change our higher and lower ranges, hit run, and we see that we've got our spring in there and our bolt moving up and down through the square washer. So that's two ways of creating a spring that can move up and down through a washer. So if you're still with me, you've got this far, but remember what we were saying about the variable and the external file, that if you're going to move on to doing the Python or save this away and come back to it, then you'll need to remove that function from the helix. Otherwise it will break the external file, but you can easily get back to it with the fix that I showed you earlier. So come into the height, click on the function, and just remove that out there of this assembly and clear that, and that's all good, and we can save that. Or if you get in the error, go into the spring and do it from the height in the same way. So come into this function, if that function's there, just remove that and remove the reference as shown before when we started this video. The tool that's available in Assembler 4 to actually drive animation is only designed for testing. It's not the full animation suite. To deliver your animation, you need to actually code that in Python. The animation tool is there to help you, but it's not to produce the final output. But we'll be going over that in our next video. So that video will be coming up in the Scripting Sunday video, so that's this weekend. So stay tuned for that. Or if you come to this after it's been released, there'll be a link here to view the contents of that video. If you like what you're seeing, please subscribe to my site. And also I have a Ko-Fi site where you can actually donate a few pence or a few pounds, dollars, or whatever your currency is. And that's at ko-fi.com/mang0. And there you'll be able to help me fund my site, and all the money that I actually get from any funds will actually get pushed back into the channel. Thanks a lot for watching and subscribing. I'll see you next time.